Good morning, everyone. Today, I'm excited to discuss a critical aspect of software architecture, architectural activities in the Rational Unified Process, also known as RUP. As future software architects, we must understand that architecture is the backbone of any software system. It's not just about writing code, it's about creating a well structured, scalable, and maintainable foundation for software. Think of software architecture as the blueprint of a skyscraper. If the foundation is weak, the entire building can collapse under pressure. Similarly, if the software architecture is not well planned, the system can become unstable, unscalable, and prone to failure. This is where the rational unified process plays a crucial role. RUP is not just a development methodology, it's a structured, iterative framework that ensures that software is built on a strong architectural foundation. In this talk, I will cover the four key phases of RUP: inception, elaboration, construction, and transition, and also how they contribute to the software architecture. Secondly, the core architectural activities, which include analysis, synthesis, and evaluation, which helps in designing a robust system. By the end of this discussion, you will understand how software architecture and RUP go hand in hand to build scalable, high performance, and maintainable software solutions. Software architecture in RUP framework. Now, before we dive into RUP, let's take a moment to reflect on why software architecture matters. Have you ever used an application that crashed unexpectedly or lagged under heavy load? Have you come across software that was so complex that even minor changes led to unexpected bugs everywhere? These issues arise because of poor architectural decision. A well-defined software architecture ensures scalability, maintainability, performance efficiency, and security. RUP integrates these architectural principles from the very start, ensuring that the teams don't just build software, but build it right. Now, let's go through how RUP ensures architectural excellence through the key phases of RUP. Okay, so the main key phases include inception, elaboration, construction, and transition. So, firstly, talking about inception. Inception phase is essentially laying the architectural vision. The inception phase is the foundation stage where we focus on understanding the business goals and requirements, identifying key stakeholders, evaluating technical feasibility. From a software architecture perspective, the phase is crucial for defining high level system architecture, identifying critical system components, establishing architectural constraints. At this stage, we might experiment with different architecture patterns like layered architecture, microservices, or event driven architecture to see what fits best for the project. Okay. By the end of this phase, we should have a basic architectural blueprint that will guide the next stages of development. Second, it is the elaboration phase. In this phase, we refine the architectural design. The elaboration phase is where the real architecture planning happens. Here, we identify core system components, define interfaces and data flow, assess architectural risk. This phase is critical because a poor architectural design can lead to a serious technical debt later. For example, if we don't consider scalability at this stage, the software might fail under heavy traffic in the future. If we ignore security considerations, it could be vulnerable to cyber attacks. To avoid these problems, prototyping and proof of concept (POC) development are often done to test architectural decisions. At the end of elaboration, we should have a well-defined software architecture, a risk assessment plan, and thirdly, a technology stack selection. This ensures that we are on the right track before full-scale development begins. And third, we have construction phase, bringing the architecture to life. The construction phase is where we implement the architecture. Here, developers write code based on architectural designs while ensuring proper modularization to separate concerns, adherence to design patterns like MVC, which is model view controller, singleton, or factory. Third, continuous testing to validate the architecture. This phase is not just about writing code, it's about making sure that the architecture work in real world scenarios. For example, if we design a microservice based architecture, we now test how well these services communicate. If we plan for database sharding, we validate if data distribution is working efficiently. If architectural flaws are found, we refactor and optimize the architecture to improve performance. By the end of this phase, we should have a fully functional system that aligns with our planned architecture. And at last, transition phase. It ensures architectural stability, to say the least. The transition phase focuses on deploying the software and ensuring that it works as intended in real world conditions. From an architectural standpoint, this phase is critical for performance tuning, ensuring the system runs efficiently under load. Security audits, checking for vulnerabilities before deployment. Third, user feedback collection, identifying usability and architectural issues. A successful transition means the architecture is stable, secure, ready for real users. Next, we'll delve on to the second topic of our discussion, which are architectural activities. Okay, now that we understand RUP phases, let's talk about the key activities that ensures a solid software architecture. First, architectural analysis. This step involves identifying business and technical requirements, assessing scalability, security, and integration challenges. Third, studying existing architecture for better practices. A deep architecture analysis ensures that we choose the right approach instead of making hasty decision choices. Secondly, we have architecture synthesis, designing the solution. This is where we choose the right architectural style. Should we use monolithic, microservice, or serverless architecture? Also, in this step, we define system modules and integration interactions. Next, select technologies and framework. At this stage, architects make decisions that directly impact software performance and maintainability. Third, we have architecture evaluation. Even the best design needs validation. Architectural evaluation involves load testing to measure system performance, security testing to identify vulnerabilities. Third, code reviews to check adherence to architectural guidelines. These steps ensure that our architecture is not just theoretically good but practically effective. Conclusion. Why software architecture and RUP go hand in hand? Software architecture is not just about coding, it's about building systems that last. Without proper architectural planning, software can suffer from scalability issues, failing under high user traffic. Second, security vulnerabilities leading to data breaches. Third, technical debt, increasing maintenance costs, and many more like this. The Rational Unified Process, RUP, helps architects and developers work together to build systems that are robust, scalable, and maintainable. If we, as software engineers, master software architecture principles and integrate them with RUP, we can build software that doesn't just work today but stands the test of time. Thank you for your time. I hope this session has given you valuable insights into how RUP and software architecture go hand in hand. Thank you.